coming from the homework right here, number 2. Yeah, it's on the back of the homework.
Why is wrong? I'm on the wrong side.
Oh, you're on the wrong side?
Yeah.
Did you put true?
Yeah.
Alright, so number 2, let's go with Lauren.
Thermochemical is the study of heat changes in accompanying chemical reaction and phase changes in a mixture.
That is correct. Alright, Claire.
Energy is the ability to do work or procedure. Heat. True.
Number 4, Sam.
Potential energy is the energy of motion. That's false.
And number 5, Michaela.
In thermodynamics, the universe is defined as the system of the surroundings connected to.
And number 6, Jake.
The elements nitrogen and oxygen are diatomic gases in the standard states, therefore the standard enthalpies of formation of these elements are zero. The nitrogen or oxygen gases are reacted to form 1 mole of NO2. The enthalpy of reaction is also zero. Therefore it's false.
Number 7, let's go with Hannah.
During a chemical reaction, the chemical potential energy of a substance is released as kinetic energy, and it's simply false.
Number 8, Michaela.
First seems nice, spontaneous process, and it's false.
And number 9, Claire.
Free energy is the energy that is able to do work for reactions that take place at constant pressure and temperature. I said true.
Number 10, let's go with Sam.
A combustion is the reaction of fuel with oxygen. Put down true.
Number 11, Lauren.
A spontaneous process is the physical or chemical change that occurs with no outside intervention or input. True.
12,
I thought we were just going to skip over this because we already answered.
we did.
Yeah. Remember there's like
Oh yeah, there are.
same.
We'll just get some more points for you. Garrett.
Okay. Energy is the ability to do work or produce heat. I put A.
And 13, Claire.
The equation is given below is a thermochemical reaction. I am not correct. Okay, A. True.
14, Lauren.
The symbol H is used to represent heat, and it's false.
And 15, Hannah.
Enthalpy is the measure of the number of possible ways that energy of a system can be disrupted, and I said A.
16, Chris. No. Claire.
I don't know how to say that.
Enthalpy.
Enthalpy is the heat content of a system at constant pressure. I said A.
And 17, let's go with Cody.
The kinetic change for a reaction can be calculated by adding 2 or more thermochemical equations and their enthalpy changes. I put false.
And 18, let's go with Michaela.
During a chemical reaction, the chemical potential energy of a substance is released as heat. I bet true.
And 19, Jake.
Chemical potential energy is stored in the chemical bond of a substance and put true.
And 20, let's go with Garrett.
A gas that occupies a volume of 2.4 liters and 14.1. What volume will the gas occupy at 84.6? I put C.
And 22? Let's go with Cody.
At 20.20 degrees Celsius, the gas exerts the pressure of 8.532 atm. After heating the tank, the pressure of the gas increases to 10.406 atm. What is the pressure of the heated gas? And I said C.
33. Garrett.
Is that ethylene?
33. Yeah, ethylene.
Okay. And the ethylene a gas torch requires 3,200 liters of gas at 3 atm. What will be the pressure of the gas if ethylene is supplied? And it is C.
And 34. Okay, it says a sample of gas occupies 17 milliliters at negative 112 degrees Celsius, assuming the pressure is held constant. What volume does the sample occupy at 70? And you're trying to find the equations with the delta H, whereas the summation equation, you're going to look at a table, like table R11, and that's in the back of the book on page 975. And you'll see that that's for the formation, so they're giving us these values here, right? So if we try to use those values to solve for the problem in the homework last night, number 1, I was having difficulty getting the same answer that I got when I did it the Hess law way. So if I got rid of the fraction and just multiplied everything by 2, my numbers is not the same. So you can see here, well, the table's on page 541 is the actual, 540 is the summation. I think we said 945 was the table. So if we go to the table and we find the values, the value for CO2 as a gas is 393.5, H2O as a gas is 241.8, and I think that's acetylene is 227.4. And if you're following the balanced equation, you multiply that times 2, that times 2, that times 2. It doesn't equal out to be, I think the answer is 235. So, right, 235, which is what I'm getting doing Hess law. So some of these can be a little bit difficult because of the fractions. Just bear that in mind. I think the fraction is causing a problem, even though this is 0, has a heat of formation of 0. Do you produce any Gibbs free energy? Now, when they say free energy, for us it's going to be a waste. So do we produce any energy that's kind of like wasted?
Any undigested food or waste product?
Well, like your body is warm right now compared to like snakes. Snakes are, I believe, home. We're homothermic because we have one temperature. And snakes are poikilothermic because they have multiple temperatures. So Gibbs free energy is energy that is available to do work. Thus, free energy is useful energy. So remember that when you're like burning wood, you're gonna have some free energy available to do more work. Now, endothermic reactions, do they typically have a lot of free energy? Endothermic? No, they're sponging off of you. There are people that are endothermic. You'd be like, come on now, go be an endothermic on me. Is this spontaneous? Delta G, 222 kilojoules. Anybody? Is it spontaneous? The reaction.
No, it's non-spontaneous.
What's the number negative?
Right, that's a good question. So it's not, it's positive.
Because
So
if the system is positive, the reaction is non-spontaneous.
right, that's the whole point that they're trying to get you.
Positive, non-spontaneous.
So table 15.6
Yes.
is the important one they want you to keep in mind. So in our situation, it was positive.
But if it wasn't, it would be spontaneous.
Right, and the values they gave to us tell us that it's right here. It says whether it's spontaneous, if it's negative or positive. You have to look at your values over here. If it's a lower temperature, so you're gonna need to keep that in mind. But if you see a positive for delta G, you're gonna consider it to be never spontaneous or not spontaneous.
And 202.0 Celsius by the complete combustion of 12.5 liters of methane gas, and it's D 1.2.
32, Nate.
Gas is confined in a still tank with a volume of 6.982 liters at 20.2 degrees Celsius. The gas exerts a pressure of 8.532 atm. After heating the tank, the pressure of the gas increases to 10.406 atm. What is the temperature of the heated gas? I got C, 84.5 degrees Celsius.
All right, 34. Simon? You got 34? What? 34?
1 second. B.
Can you read it for me though? G, bacteria will consume and make more. Now you got BO. So Nate, why do we have BO?
Letting off, is it like some sort of chemical reaction? Letting off smells.
Dogs don't have BO.
Dogs don't?
Well, the smell like dogs, that's its own type of odor.
Bacteria like
Now from what I've read, we have BO so that other animals won't eat us. Like skunks smell really bad. Now if you don't shower for like a month and you go run around the neighborhood and you come back in, you sit down, you'll be like, it smells pretty bad. I can remember the military was a little bit like that.
Why do some dogs smell before you walk bathe them?
I don't know, that's a question, but I know that BO for us is kind of a defensive mechanism, so the bear won't eat us. So if you play dead, you got BO, he probably won't eat you. Gabriella?
During chemical reactions, chemical potential energy of a substance is released.
And 19. Diana?
Chemical potential energy is stored in the chemical bonds of a substance. True.
And 20. Let's go with Sierra.
A gas occupies a volume of 2.12 liters.
Hey, which one is it? This one or this one?
The bond below it, 72.5.
84.6 kPa. And I got A.
Very good. All right, so on the overhead, correction, the board up here is a review of your homework last night. So I'm going to come around and check that in a minute. So if you put that problem on your homework, then you'll get it right.
Which one is it?
That is, I believe, number 2. Number 1 is on the YouTube video yesterday. All right, number 21. Go ahead, Austin.
21,
Yeah.
the SI unit of heat and energy is C.
And number 22. 22. Nobody get 22?
22. No, it's A.
Can you read for me?
What, 22?
22.
Calculate the energy in joules. A.
And number 23. Michaela?
Convert this energy to joules, and I got B.
Okay, if you're talking, I gotta take your points. And number 24. Dinah? C is correct. And 25. Let's go with Christian. C is correct.
A milkshake is sipped through a straw at a noted pressure. The straw contains 5.0 milliliters of liquid. How much liquid is consumed as
D is correct. 43. Diana.
How much heat is involved from the 0 heat of according to the equation to calculate heat? B.
And 44. Gabriella.
What volume does 0.0685 mole of gas occupy as heat? C.
44, it was B. 45. Let's go with TT.
Planck's law of thermodynamics state that entropy is always increasing. C.
46. Diana.
1 calorie equals like D.
And 47. Diana.
Gas is contained in a metal tank configured as 20 the gas exerts a pressure of 8.532 atm. After heating the tank, the pressure of the gas increases to 10.406 atm. What is the temperature of the heated gas? A.
Alright, so 48. We're on 48 there? Yeah, that was C.
No, 47.
Oh, 47 was A. Yeah, I'm sorry. My paperclip moved. Alright, 48. Go ahead, TT.
Quantity of gas and molecules is contained in 2.21 liters at STP and C.
And 48. 48 C. 49. We got 49?
Yeah, 50.
Okay. We'll come back to 49. Who can do 50? Go ahead, Michaela.
Okay. The amount of energy required to raise the temperature of 1 gram of pure water by 1 degree Celsius is defined as D, a calorie.
Alright, so let's do 49 on the board. 49 we have milkshake, and the straw contains 5.0 milliliters, and then they want to know how much is consumed at P1 of 0.092, and then we have P2 of 0.07.
1/7 times 5.
You're close.
If you did not
I
give me my
forgot the
Try the calculator again.
And then
So the answer is, what's the answer? What'd you say?
you said 3.9.
What's the answer on the test though? Yeah, the answer is D. 49 is D. Very good. Free energy is kind of like not necessarily a great thing when we're talking about waste. So the objective is to capture that free energy and make it into work. That's what it says right here. It says free energy is the energy available to do work. You don't want to give your work away. Make sense? Most people don't. Most people get upset when they're losing their work. And that would be the example of your automobile. It loses a lot of work through the hood in the form of heat loss. This is true with you as well. You consume your food to be smart, but a lot of it is lost in what?
Heat.
Yeah, heat. And 24. Aaliyah?
The volume of a sample of helium is 4.5 milliliters at 20 degrees Celsius. What is its, what will its volume be in the figure? And I said C.
C is correct. And number 25. Let's go with Melanie.
What will the volume of the gas in figure 3.4 be if the temperature is constant and it's C?
26. James.
1 joule is the equivalent of 1 calorie. I put C.
27. Josh.
4 liters of gas at atmospheric pressure is compressed into a 0.85 liter cylinder. What is the pressure of the compressed gas and the temperature remains constant? C.
28. Annette.
Okay. The volume noted in the figure contains nitrogen gas under a pressure of 4
And 29, Andrew. Andrew, you got 29?
Yeah, sure. Hold on. Burger. A burger contains 220 nutritional calories. Convert this energy into food. I got beef.
30. Let's go with Zaria. About how if you crack an egg, you can't unscramble the egg. And then we talked about how are you going towards order or disorder? Yeah, are you as a human being moving towards order or disorder? Yeah, and you're moving towards order, why?
To decrease the amount of disorder?
No, to reproduce. You have something called hormones, and those hormones will drive you to reproduce. That's the goal of your hormones. Now, it's very important to build the nest like the baby bird builds the nest, or the mama bird and the papa bird build the nest first before they have the baby birds. Why do the birds build the nest first, Jack?
Because they need to have a supporting foundation for their baby.
Because the cat will come along and eat them.
Yeah, that's what I'm talking about, right there.
So this is true, Andrew. This is true in life. So remember, once you can no longer, Zadie, once your hormones no longer work, then you'll see like this place called 35 again, where they give you hormone testosterone replacement, because they're trying to keep you moving towards order. When that body is being productive to make other life, because life, the production of life is an ordered thing. That's how we know that we have life. Life is considered to be ordered, and then non-living things are considered to be disordered. Let's get that in mind. Now, they introduced today Gibbs free energy. What do they mean by that? Now, when you eat food, Andrew, do you waste any of that food?
No.
Yes, you do. And what is the waste of your food going?
Vegetables.
Where's the waste going?
In your butt.
No, it actually moves through your skin as far as heat is concerned. Your body has to heat itself, and some of that heat is lost in the form of waste. Yeah, but you would rather eat less and then do more.
You did really good though.
So keep that in mind, that when you eat food, some of it is like gasoline would probably be a better example. It would be nice just to fill my car up once a month instead of 4 times a month. That loss in heat on the hood is called Gibbs free energy. It's this energy to do work. Unfortunately, the engine is not grasping that heat and converting it into work. And then other people try to. So I don't want you to think they're trying to steal your free energy, but if you're not using it, people will think, well, it says in the book that it's free. All right, so the work is up here on the board for the homework problem number 2. Number 9, Josh.
Free energy is the energy that is available to the work for reactions that take place at constant pressure and temperature. 9 is true.
10, Brendan.
Combustion is the reaction of a fuel with oxygen.
11, Sean.
A spontaneous process is a physical or chemical change that occurs with no outside intervention.
12, Josh.
So energy is the ability to work or produce heat. 12 is true.
13, Giovanni.
The equation is given below is a thermochemical equation as a
14, Courtney.
The symbol H is used to represent false. No, that's not true. No, wait, 14?
Yeah.
False.
15, Brendan.
Entropy is a measure of the number of possible waste energy of the system being distributed.
16, Josh?
Enthalpy is the heat content of a system at constant pressure. 16 is true.
17. Josh?
The kinetic change for a reaction can be calculated by adding two or more nominal chemical equations and their enthalpy change. 17 is false.
18. Sean?
During a chemical reaction, the chemical potential energy of a substance is released as heat at
19. Alex? Got the 19? All right. You lose points in talking.
Wait, I got that one right.
All right, let's go with Trevor. And number 20? Giovanni?
Gas oxides a volume of 2.4 L at 14 weight, 1 kPa. What volume will the gas on heat still run at 84.6 kPa? And I got A.
And 21. Let's go with Trevor.
The SI unit of heat